In this instructional video, we will cover solving absolute value inequalities. Essential question: how can you solve an absolute value inequality? The objective is to formulate and solve absolute value inequalities. Please do not forget about these tips right here. Remember that I will be checking for your name. Make sure you're taking notes in Cornell note style. I expect to see you try problems, and I need to see your summary. I take away 15 points if there is no summary. Feel free to press pause, to rewind, or to fast forward according to your needs. So let's begin with vocabulary. An absolute value inequality is an inequality that contains an absolute value expression. So we've been dealing with absolute values with equal signs, right? So now we're going to be trying to find x when we have the inequalities that we have learned already in our math classes. Okay, so let's go ahead and begin by reviewing the symbols. Okay, so we know that this symbol is the equal sign, and whenever we find a solution with an equal sign, we know that we just need to plot a solid dot to represent that solution. That means that that number is included in the inequality or equation. Now, let's go ahead and review the inequalities. We have the greater inequality. Now, I just wanted to remind you that this one doesn't have the equal sign underneath, right? So that means that the solution could be any number greater than, but not equal to. So then that means that whenever we're plotting it on our graph, we need to use an open circle because it means not included. Now, since it is greater than, then that means that we're going to have an arrow pointing to the right. The next one is less than. Alright, so the same way as the one before, we do not have an equal sign. So this one also means not included. So we're going to begin with an open circle. Since it's less than, our graph is going to point, our arrow is going to point to the left. The next one is greater than or equal to. So this time we do have that equal sign underneath the inequality. So then that means that my solution is included, my number is included on the solution. So we're going to use a closed circle, and since it's greater than, it's going to point to the right. The last one is less than or equal to. So that means that since it's equal to, we're going to have a solid dot, and since it's less than, it's going to point to the left. Okay, now we're ready to begin with our problems. So go ahead and write example 1. We're going to be solving absolute value inequalities, where the absolute value is greater than the constant. So in A, we have the absolute value of 8 plus 6 divided by 2 is greater than or equal to 16. Okay, so if this was an equal sign instead, we know that the first thing to do is to leave the absolute value completely alone. Okay, so that's the same thing that we're going to do, is just that this time we have an inequality. So step number 1, we got to make sure that this absolute value is by itself. So we are dividing by 2. So the inverse operation would be to multiply the top by 2 so that those 2's could cancel. Now what we do on one side, we have to do it on the other side. So let's go ahead and bring down the absolute value of A plus 6 is greater than 16 times 2 is 32. Now we are ready to split it up. Okay, so it's the same process that we've been using with absolute value equations. So remember that we need to set it equal to the positive of 32. Now I am going to use the same inequality. Now, what happens with the inequality anytime that we multiply or divide by a negative number? The inequality flips, right? So that's what we're going to be doing whenever we're going to write the negative number. So we're going to write A plus 6, but I'm going to flip the inequality because now I have a negative 32. Okay? So now we're ready to roll. Now we're ready to solve. So I'm going to subtract 6 on both sides, and we get A is greater than or equal to 30. Now let's do the other side. Subtract 6 on both sides, And I just caught my mistake. I wrote 36 instead of 32 on this side. So instead of us having 30 here, it's supposed to be 26, okay? All right, let me go back to the one that I was working on. So now we're going to have A is less than or equal to negative 38. Now, both of these are my solutions, okay? That means that A could be any number greater than or equal to 26, or it could be any number less than or equal to negative 38. So now what we're going to do, we're going to go ahead and graph our answers in our number line, okay? So I am going to begin with the 0 here. And since we have 38 and 26, I'm going to go up by tens. So 10, 20. So now, we have equal to, so we're going to use a solid dot. All right, so let's begin with the 26. So I'm going to go ahead and place a dot on 26, which is somewhere around here. Now, since A is a number greater than, then my arrow is going to point to the right. Now, we're going to plot another point on negative 38, which is somewhere over here. Since A has to be less than negative 38, then that means that my arrow is going to point to the left. That shows all the numbers, okay? So the arrows represent the solutions that we could use for A. Let's go on to B. B, we have negative absolute value of G over 5 plus 6 over 7 is greater than negative 5. So, number one, we have to leave the absolute value by itself. So what I'll do, I like to begin with the coefficients, okay? So I have a positive 6 over 7, so I'm going to subtract that 6 over 7 on both sides. Now I'm going to show my scratch work over here. I know that I have to do negative 5 take away 6 over 7, right? So I need a common denominator. In order to do that, I'm going to multiply top and bottom by 7. So then we're going to have negative 35 over 7 subtract 6 over 7. Now we're ready to subtract them. And we get negative 41 at the top. So now we're ready to bring the rest down. So negative G over 5 is greater than negative 41 over 7. Okay. Now I need to get rid of that understood negative 1. So what I'm going to do, I'm just going to go ahead and divide by negative 1. Or we could multiply by negative 1. I think that'll be easier. Right? So times negative 1 times negative 1. So I mean basically we're just changing the signs, right? So we have G over 5 is less than positive 41 over 7. I flipped it because as a rule, when we multiply or divide by a negative number, we flip the inequality. Okay? So now, the next step is to go ahead and divide what's, to split and solve for G over 5 twice. So, the first one is going to be G over 5 is less than 41 over 7. And then the second one is going to be G over 5. Now, I know that it's a less than, but remember, we're going to go ahead and switch the inequality because we're adding a negative now. Now, in order to solve, I'm going to go ahead and, since it's G divided by 5, I'm going to go ahead and multiply both sides by 5, all right? Remember that it's the same thing as 5 over 1. So it's going to be G is less than. Now we just multiply across. Alright, so this is one of the solutions. Now what we're going to do over here, we'll do the same thing. We're going to multiply by 5 on both sides. Okay, so then we're going to have G is greater than negative 2 over 5 over 7. Now, this right here is around 29.2, okay? So this is around negative 29.2. The reason why I am just showing you the decimals is because we're going to have to show our answer on our number line, okay? So I'm going to put 0 here, and then I'm going to go up by tens. And then the same on the other side. Now, this right here, the inequalities, do not have the equal sign. So then that means that I'm going to use open circles for both. So I'm going to begin with this one, positive 29.2. So somewhere around here. Now we know that that has to be less than. So we go this way. Okay. And then we have a negative 29. Oh, I said open because it's not included. And we go to the left. Now, it's a negative 29.2, so we're going to put an open circle because it doesn't have the equal sign. But this time it's saying that g is greater than, so it goes this way. So since they meet, then that means that we're just going to have a solid line joining them together, okay? So you just have to be very careful, guys, when you're graphing these. If they point towards each other, it's just a solid line in between our two dots. All right, next two examples. Solving absolute value where we have a less than. So the first one we have the absolute value of 9 minus 4n is less than 5. So what we're going to do here is, since the absolute value is by itself, then that means that we're ready to split it up into 2. So first we're going to have 9 minus 4n is less than 5. And then on the other side, 9 minus 4n, we flipped the inequality because now we're going to have to do it by a negative 5. Now we're ready to solve. So let's go ahead and begin with the constant. We're going to subtract it on both sides. Now I'm going to bring down negative 4n is less than negative 4. Now we're ready to divide by negative 4. Okay? So don't forget, when we divide by a negative number, we flip the inequality. So now let's go ahead and do the same thing on the other side. Okay, so this is what we get when we subtract by 9. Now let's divide by negative 4. So we flip the inequality again. And now we're going to have, if we reduce the fraction, a positive 7 over 2, which just for graphing is around, well, it's actually 3.5, right? So let's go ahead and graph our answers on a number line. So we have a positive, so I'm going to put 0 here, negative 1, 1, 2, 3, and 4. Okay, so no equal sign, so then that means that we need an open circle, and I'm going to begin where n is 1 here. Now it's greater than, so we point to the right. Now we have a less than 3.5. 3.5 is somewhere here, and we're actually going to go to the left because it's less than. So since they meet, this is basically just a line connecting both of my circles. Okay? All right, B, we're going to have 4 plus the absolute value of 1/2 x minus 1 is less than or equal to 38. So the first thing that I'll do is to leave the absolute value by itself, but I need to scan for the constant. My constant is right here. It's a positive 4, so I'm just going to subtract it on both sides. And we end up with the absolute value of 1/2 x minus 1 is less than or equal to 34. Now we're ready to split it up into 2. So we're going to have 1/2 x minus 1 is less than or equal to 34. And then 1/2 x minus 1. Now, don't forget, flip the inequality to solve, okay? So now let's go ahead and add 1 on both sides. And we have 1/2 x is less than or equal to 35. Now, in order to get rid of this 1/2, I am going to multiply by the reciprocal 2 over 1. Now, don't forget that this 35 also has a 1 underneath, okay? So that cancels out. So we are left with x is less than or equal 70. Okay? Now, the second one, let's go ahead and do it. Now I'm doing the same process. Adding 1, multiplying by the reciprocal. So x is greater than or equal negative 66. Okay? So, alright, so I went ahead and went up by 10. So the first one is x is less than or equal to 70. So Since it's equal to, I need a solid dot, and then it's less than, so it's gonna point to the left. And now we have x is greater than or equal to negative 66, which is somewhere over here. Close dot, and it's greater than, so it points to the right, so they eventually meet. So it's a solid line in between them. Alright guys, we're gonna do special cases next time. So what I want you to do is to work on these try problems. It's 3 of them. Actually, I am gonna take one away. Do not do number 3. So I only want you to do problems 1 and 2. We'll leave this for later on. Okay, so don't do number 3. And I want you to write your summary as well. So this can help out. How is solving absolute value inequalities similar to solving absolute value equations? Just in case you can see it. That's what it says. And then how are they different? So you're comparing and contrasting solving equations with the inequalities. See you in class.